Hi, thanks for stopping by, thanks for watching. This is my first attempt at this, so I'll just kind of wing it and we'll see how it goes. I have on my bench here a Coleman branded Powermate 800 watt power inverter, 1600 watt peak, 800 watts current, constant load, and it's a pretty nice unit. That's the heatsink slash case from it. It's kind of a beast. It's nicely constructed and not inexpensive, so I'd sure like to get it going again. It just stopped working. It won't power up, won't do anything anymore, doesn't make any noise, no fans run, nothing. So let's go inside, take a look at this thing and see what's wrong. It was in a pretty harsh environment out in the barn. It was living with a bunch of chickens and they were unkind to it, so who knows, but we'll get inside and check it out and see what we got. Okay, here's the insides of that inverter. It is filthy in there. Look at the dust built up back there. It's no surprise this thing is having problems. Ew. Okay. It won't power up, and it doesn't appear to have any blown fuses. Well, there doesn't appear to have fuses inside it at all that I can see so far, but it does absolutely nothing. And one of the first rules of troubleshooting is check the simple stuff first, because if you just gloss over it and bypass the simple stuff, it'll always bite you in the end. We'll clean this thing up before we put it back together, but right there on the front, look at all the gunk on it. That's the power switch. Let's check the condition of that power switch. With all the gunk and grime and filth in there, I wouldn't be surprised if mechanically that thing has failed. Let me get a meter hooked up. Be right back. Okay, I got some alligator clips hooked up to it, and with the switch turned off it reads 36K, and we'll switch the switch on. Oh, nothing happens. Okay, that switch is not doing what it's supposed to do for sure, but I'm going to show you something else, another a trick you can, well, it's not a trick really, it's another way of measuring the condition of a switch like that. In the open position, you should have an open circuit, infinite resistance, and when the switch is on or closed, in this case, you should read 0 volts across that switch. This is the voltage drop. Open would be open circuit, infinite resistance, and all of the voltage dropped across the two terminals of that switch. There's my two switch terminals that I'm hooked up to there with the alligator clips. So let's power this thing up and give that a measure. Okay, now I've got the circuit powered up. Got my alligator clips hooked up to that. 13.4 volts measured across those two terminals of that switch with the switch off. Now if I switch the switch on, if the switch were conducting, that should drop to 0 volts. 0 volts difference between those two terminals. And not a lot of change. It's conducting a little bit, but it's acting like a big resistor and preventing current flow through it. So that switch is no good. No good at all. And from all the, you know, you can see all the filth it's been subjected to. It's no wonder. We'll just get a new one of those in there and see if that makes a difference. Incidentally, if you're fooling around with inverters, these plugs here on the output side, these terminals that are exposed when you have it open, not a good idea to go monkeying around with those while the device is powered by 12 volts. The output side is in the United States anyway, 125 volts, and this is an 800 watt constant load inverter. That it'll kill you if you touch those under the wrong circumstances. So be careful with these things. Let's put a new switch in there and power it up again. Okay, there is our brand new switch installed. Looks really out of place now. Jameco had exactly that switch. Can't read it, but a search for that part number on Jameco turned up exactly the right replacement. So let's power it up, and alright, we have 13.4 volts drop across that switch like before with it turned off. Now let's turn it on very carefully. Careful around all this stuff, don't touch the wrong thing. You can hear that fan spin up, and the voltage drop across the two switch terminals is 0, as it should be, because it's essentially a wire at that point and not like a big resistor. It's a closed circuit, not an open circuit anymore. So well, we've done some good here. I hear it running. I don't see any power lights on the front. Let's hook up an appliance to this thing and see if it runs. Alright, the only thing I had handy is a Dremel tool here. So I've got that plugged in, the inverter's powered up, and we'll switch the Dremel tool on. You'll be able to hear it, but you can't see it where it is. Good deal. I would call that a, well, at least a partially repaired inverter. I don't know why the LEDs don't come on to tell me it's powered up, but everything seems to work so far. I'm a little worried about this fan back here with all that dirt inside the thing. I bet the fan bearings are not long for this world yet. That's probably the next thing going to go bad on this machine. Anyway, not bad. We'll get it cleaned up, put back together, and see what we can do with it. Well, now that's interesting. I couldn't let this go. I couldn't clean this up and put it back together without knowing why this power LED wouldn't come on. There's the old one there. I ended up pulling it out because both of these LEDs in the front panel here. Oh, sorry. Both these LEDs in the front panel check open, like they received over voltage and blew them up, both the green and the red. So I just stuck a new green one in there, and sure enough, it lights up. I'm going to replace that red one too while I'm in there, because it also tests like something has burned it up, which is a little creepy. Yeah, I don't have an answer for that. I know how that happens. If you take a 9-volt battery and hook that direct up to a little LED like that, it'll just burn. It'll come on really bright for half a second and then just burn, and it doesn't work anymore. And that sort of looks like what happened. I can't. Yeah, that's weird. Anyway, replace the red one, then we'll clean it up, put it back together. Okay, there's our inverter all cleaned up. I've got it hooked up to power. Let's bring it up here. Alright, power supply is on. Power. Got a fan, got a nice green power light. I've got an old side table lamp here with an incandescent bulb in it. Let's test with that. Plug that in, turn the lamp on. Hey! Wow! It's pulling 10 amps from my power supply. It must be a 100-watt bulb. But it's doing it. Alright. Success! Well, there you go. I'd say we got pretty lucky that that's all it was, but there it is, all spiffed up and ready to use again. I don't think I'll put it back in the chicken house though. I think I'll give it something better to do. But pretty good. I've got another inverter to tear down and repair too. The same one that, another one that didn't work during the same storm that I needed this one to work. So I'll make another video on that. If you liked what you see, leave a comment. I'll keep doing these things. Thanks.